Okay. So hi everybody. Thanks for coming tonight. I'm Guy Podjarny, or Guypo, and I'm here today to talk to you about the security concerns related to NPM, or the vulnerabilities in NPM. I'll have like a handful of slides, and then most of the time we're going to spend in the terminal, kind of looking at an application that's vulnerable, understanding it. Yeah, just sort of going through those. I will give myself an excuse up front. I come from London, where I live, so unlike Keith, my jet lag is the other way around. So if I say something silly, I'm just going to jot it to the fact that it's like somewhere late at night for me right now. And that beer was not a good idea. Switch to water over here. So a little bit of sort of setting the stage. We all know NPM is awesome, right? NPM sort of started off, today NPM is a core tenet of how we develop in Node. It's kind of hard to think of how would you build a Node application without sort of this great strength of, everybody else's work that's sort of been built into us in Node. And as a result, NPM usage has exploded. Every time I need to update this slide, I don't even know where the exact numbers are. I think they're actually past 1 billion downloads a week. At this point, there's this huge, massive usage of it. Also, all sorts of concerns, fragility, the whole left pad, Azer issues, but definitely a lot of adoption, a lot of usage, a lot of growth, both in terms of how many packages are on that system, as well as how many packages we consume and how do we use them. And when you look at a typical Node application today, this volume manifests very clearly, right? You look at a typical Node app today, it has at least tens, if not hundreds, sometimes thousands of different dependencies. Some would be duplicates of the same package of different versions. Some would be brand new versions. Oftentimes, most of those you did not pull in directly. You pulled in a package, which pulled in a package, which pulled in a package, and you have sort of this chain of dependencies in there, which results in kind of this view where this is your app, and this is your code. And this might look like a negative slide, but it's actually a positive slide. It's a good thing, right? You could build all that value by just writing this much code, which is a good thing. However, it's also scary. Each one of these dependencies is code that somebody wrote that you're running in your system. And what do you really know about those dependencies? Do you know for each one of these components if it has vulnerabilities? Do you know how security conscious was the person that wrote it? Do you know if they were using any security tools? There's a bunch of these concerns that we tend to overlook today. We don't really give them much thought, but we're just writing some stranger's code in our system. So this is a bit of a fundamental problem in today's open source world, right? It's not clear who owns open source security. Should it be the one creating an open source package? Do you really expect an unpaid developer creating some open source package, creating Nodal, creating some component to understand security, to use security tooling, to drop everything when there's a vulnerability and go fix it? It's kind of unrealistic. And at the same time, all of us, when we consume open source, we're consuming hundreds of these different units, and we don't understand this code. We did not write this code. So generally the tendency is to think about this as off-the-shelf software. We kind of purchase it, and just like we expected in the past a vendor to handle their vulnerabilities, we do the same here, right? We just expect that the author would have written it, not really giving it much thought, or we just don't think about it at all. So this is a big security concern. Over time, there's a lot of things to do about it. There's no easy solution for it, but I would posit that the simplest step, the first step that we can do to address this is to look at known vulnerabilities. So to demonstrate this, we're going to leave Keynote here, and we're going to switch to the browser and the app. Oh, this is brighter than my terminal. And we're going to use a real application. It's not real, it's a demo application that is unusually vulnerable, has more vulnerabilities than average. And what we're going to do is we will understand this application, look a little bit at the vulnerabilities it has in it. We'll do some exploits to sort of understand the impact of those. Why should you care? How do they come to be? Hopefully teach you a little bit about how to not have those vulnerabilities in your own code. And then we'll talk about, of course, how to remediate those issues. So this is web dev talk, so clearly we have a to-do application. To do this is a nice to-do application. You can say that you want to buy milk or call mom or do something like this. It also has an about page, sort of talks about how awesome this this application is, and it's an application, it's express-based. So the application is running here. It's called Goof because it goofed a little bit a few times. So let's take a look a little bit at this application. It has, if I go in here and I do npm ls, I will see that it has a bunch of dependencies that it's using. It's not an unusually large number, but this is just a bunch that it's pulling in. And again, we're sort of concerned about potential security vulnerabilities in it. So to do that, we're going to use the tool that I work on, Snyk, which is a free tool. You can do npm install Snyk. So you would have done npm install -d Snyk, and I've already done that. So I'm just going to go straight into what's going on here. For some reason, my word delete doesn't work. And I'm just going to run Snyk test in this application. And what Snyk test is going to do is it's going to look at these dependencies, enumerate them, match them up against an open source vulnerability database that we have, and tell me which vulnerabilities were found in this system. So in this case, I tested 377 dependencies. Again, we see many of these things. This is not a large number. And we found 7 different vulnerabilities, 8 vulnerable paths. So, one of these vulnerabilities showed up twice, the same vulnerable package. Let's take a look at a couple of these. So, for starters, let me pick on the last one here, ST. So, ST, it's if you don't know it, it's a simple package written by Isaac from NPM to browse static objects. So it allows you to serve from your repository some static objects. And it looks like it has a directory traversal vulnerability that I'm using version ST version 024, and it has a vulnerability. I can go into this info link over here. Excuse the light brightness every time we sort of switch to the browser, and it would explain a little bit about this vulnerability. Fortunately, you have me here, so you don't need this advisory. You can just have me show you. So what we're going to do, sorry, I'm just going to zoom in a little bit. Showed a little bit the last step here, is we're going to play a little bit with this application. ST is being used in our browser to serve this about page. So if I go to about page, you see that it goes to /public /about /.html. And this is served with ST. Sometimes attackers can just deduce that, sometimes they can guess. When an attacker sees a resource that's potentially static, the first thing they're going to do is they're going to put .. They're going to try to sort of escape this this context to try and see something else. Now, unfortunately, if I do .. browsers do this great service and they normalize it for us and they reduce it, never really gets to the server. So instead of doing it here, we're going to do it in curl. And I have some shortcuts for myself here just to make sure I don't mistype. So we're just going to go ahead and run a curl on this about page, and we're going to get our sort of awesome complementary service here. And then because we're playing attackers here, we're going to do .. or something like this. And if we scroll up, we're going to see that we got the goof to do title. We didn't actually succeed here. Go into the code of ST, you will find that the .. is blocked. It actually is inspected in this, and they don't allow you to break out of it. However, there is a vulnerability here. The vulnerability is that while .. is captured, %2e, here I'm going to move this up a little bit, sorry. The URL encoded version of it is not captured. So I can do %2e, and I will actually be able to back out into where I have my node modules into my parent folder. So I'm actually using another vulnerability here because there's ST doesn't have a vulnerability but has an insecure default, which is by default it actually has directory listing turned on. So if I just browsed, public like this, I would actually get all the resources on this page, which is not a good thing for security. You can argue if that's a vulnerability, it's definitely insecure. So ignoring that, this was convenient for us. But if I didn't have this, what I could do is I could just do this and go on and on and on, because .. would just go as much as I want, and put like etc passwd, and voila, I can get everything here. So not good, right? A very simple vulnerability, very simple, and I can show you this because on a Mac, etc passwd is actually not that interesting, but if this was a Linux machine, this would be a vulnerable or an important file. Okay, not good. This was one vulnerability. Let's look at another. The next one I want to pick on is the marked vulnerability. So there's a vulnerability on marked. Who here knows marked? Handful of people. So marked is a markdown parser. It's a very useful component to basically take in markdown input and just be able to convert that into HTML. So in our app, we do something like, if I want to say buy beer, I want to emphasize that, right? So I think I need to do double stars, and then it's going to be bold, right? And I can do things like sneak and put links in it. So this is sort of a convenient way. It's a good way that is used oftentimes in various sort of user-generated content to be able to create this sort of more rich text environment without actually supporting HTML input. And surprise, surprise, marked has a vulnerability. So once again, if you use the snake, you would click in here and you would get all sorts of details about this vulnerability. But instead, I will show you this vulnerability. So let's get back a little bit into this. You got a little bit of a hint here, which is this is a cross-site scripting vulnerability. And how do you think I might try to exploit a cross-site scripting vulnerability in marked, right? This is markdown, it gets input. What might I try to do?
JavaScript protocol.
I can put the JavaScript protocol, so that's a good one. So basically, if I just put JavaScript colon alert 1, then nothing really happens. So I needed to put in the URL. So I would put something like this, or maybe I want AMS. I'll do something like gotcha, and I'll put as a link, I'll put JavaScript colon alert 1, right? So what you can see here is that it got trimmed. Once again, by default, this would have worked because marked just allows content in. In fact, I could have put just a script tag and it would have worked. However, not by default. You can turn on a sanitize option, which I did turn on here, which trims things that look like they might be dangerous. So scripts would have been eliminated. This would have been eliminated as well. But HTML is complicated. Just like we have URL encoding in the URL, we also have encoding in other places. So instead of this colon, what I could do is I could put, say, ampersand, pound, 58, and actually I probably need to swap this as well for 41. Anybody knows what these are called? These are HTML entities, right? So I can do this, and maybe I can overcome them this way. No, I cannot. This gets trimmed. But there is a vulnerability here, I assure you. And the thing that happens here is that not only is there encoding, there's also browsers are extremely tolerant in how they interpret all of this input. So in this case, what I can do is something like this. I've basically broken up my HTML entity and I have ampersand hash 58 this semicolon. So it's not really like a legit HTML entity, and because of that, marked would just let it through. However, browsers are very tolerant to our mistakes. So for browsers, they would look at this and they would say, fine, this ampersand number 58 did not come with a semicolon, but I'm pretty sure you meant, with a colon, sorry, well, with a semicolon, but I'm pretty sure you meant the colon. And indeed, if I click this, I would get the JavaScript alert. And clearly here I just did an alert 1, but I would put something much more sensitive here, sophisticated, to try and extract this. Not good. Marked is also interesting because there is no fixed version for it. I'll tell you how you can fix it anyway in a bit. Okay, we're going to show a couple more. We're going to get a little bit more sophisticated, right? Both of these cases, it was just this malicious input. I can show it. Let's get a little bit fancier. So the next one we're going to show is on MS. Who here knows the MS package? Nobody. So surprise, surprise, you're actually probably using it. You're using it kind of through all those dependencies that you have. It's abundantly used. What the MS package does is a very simple package. It takes in strings like 1 minute, 2 minutes, or 100 milliseconds and converts them to the number of milliseconds. So what this allows me to do here is it says call mom in 20 minutes. And what it would do is it would actually use MS to sort of parse this into the number of milliseconds, then send me a reminder later on. So useful. I told you this is the best to do app ever. So it has those components. And MS has a vulnerability. The vulnerability in MS is called a regular expression denial of service, or REDOS vulnerability. And it works like this. If I kind of look at an example, I think I'm in the wrong folder. So I just have these as helpers. So, once again, to demonstrate this, we're going to move to the terminal versus the browser, just because it's easier for us to do some replications. So, because I did, if I kind of went in and I typed in this text, what I'm doing, I'm submitting a form. I could also do the same thing in terminal, right? I could just sort of echo or content call mom in 20 minutes into a curl command. Instead of curl, I'm using HTTP, which is just it's like curl, but it does syntax highlighting, so it's just convenient for us to use here. And that would go in here, and if I refresh, it would add this item for us. So it's just all I've done is invoke this command via the terminal. But because I'm in the terminal, I can do something a little bit fancier. I could do content, whatever, buy milk in, and then I'm going to print 60,000 times the digit 5. So I'm passing a very, very, very long string. Now the thing about regular expressions is, depending on the regular expression and the string, they take a non-linear amount of time to process an input. So the time it takes them to process an input is non-linear to the length of that input. So you could have, if you have a long input, you can have a very long amount of processing time. So in this case, I will run 60,000 of these characters. Oop, what happened here? Oh, I forgot. Perfect. And it didn't really take a lot of time, right? It completed fairly quickly. Regular expressions take especially long when they do not match. So here I had 60,000 minutes, but instead of this, if I do 60,000, just going to swap the S for an A, something that does not match the regular expression, suddenly we have a different issue here. Now this takes a while to run, and who cares if the attacker takes a while to run. But what happens here now is that if I do anything here, my application is non-responsive. Now why is this? Thoughts, guesses? Single-threaded, right? The secret of scaling for node applications, right? It's an event loop, and everything is asynchronous until you have an algorithm like a regular expression match that takes a very, very long time. So even massive applications out there that are built in nodes do not have many threads running. That's good. They don't need that many threads, but it's that much more important for them in those applications that you do not block the event loop, that you do not do any algorithm that takes a long amount of time. There's another flavor of attacks that can be used on the event loop that take advantage of it called timing attacks, where you can try to see how long does an algorithm take by seeing how long does it take the application to respond from another thread. Now, they're a little bit more complex. Now, eventually, this call did complete, but if I added a 0 there, it would not have, and we would have all gone home without seeing the next attack. But so this is sort of a bad problem. Again, very simple application, very common mistake. RDOS is one of the most common vulnerabilities because it's so simple to make, right? We use regular expressions all the time, and it's very rare that we make sure that the input, the length of the input that we provide to these things is contained, or otherwise prevent this from just sort of being explosive. Yeah, infinity is just, that's just, I should have handled this better in my rendering. I'm not a good front-end developer. So we've seen 3. We're going to show 1/4, and then we're going to talk about solutions. I actually did not even check how I'm doing for time. I hope I'm not terribly bad. So the last one we're going to show is also the most complex one. It deals with something that we don't tend to look at. This is on Mongoose. So Mongoose, who here knows? Yeah, I imagine as much. Okay, so Mongoose is like super popular. This one also, the Sequelize has basically the same vulnerability. And that vulnerability has to do with buffer. Buffer is a very, very tricky element in Node. And the reason for that is, buffer is generally an object that meant to hold binary information, binary data, which is already a little bit weird for us in JavaScript. But then specifically, it supports 2 constructors. It can take a constructor that is a string, in which case it would actually initialize with that string, or it can take an integer constructor, in which case it would allocate a buffer with that many bytes in it. However, when it does so, it does not erase that memory. So you allocate 100 bytes, and it just takes 100 bytes from memory with whatever it is that happened to be in there, which is dangerous. That's basically the type of problem that happened in Heartbleed, which is like now this buffer holds some uninitialized memory, and who knows what's in there. So if I can get a hold of that as an attacker, that's a big deal. So let's look at what happened in our application. If I look at our app, and I look at, I think I have it in like db.js, I have a little schema, simple schema for my application, and it supports buffer as that content. A little bit of a stretch, it's a to-do app, but if you wanted to support, Unicodes or images or anything like that, you're likely to do this. And because it's the type of buffer, I can try and manipulate here, right? So let's play with this a little bit. So once again, I think it's the wrong. So once again, I am going to do this sort of echo content by beer into HTTP. We've already seen this. Right, this all good and well. We go back to our application and we see that we bought beer. But this is a node application. So of course we support what type of input? JSON. Of course we support JSON. Who doesn't support JSON? So instead of doing this, I can do something like this. I can say echo in JSON format, content fix the bike. The previous one was as a form input, but this is all API driven, so I support an API, I support JSON input into it. So that's all good and well. I say fix the bike, I come in here, I look, I fix the bike, awesome. So let's proceed a little bit. Here, because it's JSON, I can also say, you know, like 800, something like that here, and then I will get 800. But this is JSON. So now, instead of this string, I can also do this. And what would that do? Any guesses? Yeah, so it's not buffer overflow, but it's a buffer vulnerability. So what it would do is it would basically change the type of the object that gets deserialized to make this item now be an integer versus a string. So if I do this, suddenly I get this sort of gibberish back. This gibberish is a little bit for convenience. This is the note that just got created. This is the to-do item that just got created. If I go into my browser, I will suddenly see this binary data here. This is the uninitialized memory that I have. So this one's a little bit, I can't, without like really muddying my application, it's hard for me to show you this without, without kind of messing up my database. But I can repeatedly do something like this, which is, I will, instead of -v, I'm going to do -b, which just gives me the body of the application. And then in this case, it's base64 encoded, so I can just base64 decode it. And just sort of extract this. And if I run this sufficiently, I will get whatever secrets are in memory. So this would include source code, any keys that are in memory, anything on that system. Pretty bad. Buffer is a really, really tricky element. In Node 6, it behaves exactly the same, except you have the option to say safe alloc and unsafe alloc. So I would recommend that you don't use the default constructor, but rather use the safe alloc and unsafe alloc. Well, use the safe alloc, and if you have a really, really good reason to it, say unsafe alloc, and I hope that in the next Node version they would actually deprecate the constructor, because the problem is it's an easy mistake to do, right? You just say new buffer, and you take that object. Okay, so this was fun, but it's a little bit of the doom and gloom, and it's not much fun when it happens to you. So let's talk a little bit about what you can do to address this, right? We saw a bunch of these vulnerabilities. Sneak is the tool, like basically, yeah, sorry.
Just of those four vulnerabilities, which ones were published by the authors or by you went back to the original point was who's responsible? So I'm just curious.
Hardly any of them were found and fixed by the original author. Vulnerability disclosure in the world of open source is still fairly problematic. In the world of NPM, it's in complete crap. Really, it's like it's not being done. So most security issues get reported as an open issue that was opened on GitHub, which is not a responsible disclosure process. That's not what you should do. Some issues do get reported properly, so you email the owner. You know, at Sneak, if you find something like that, you feel free to sort of reach out to us, and we'll help you kind of go through that process. And you're supposed to go through this process of giving the author some time and basically publishing the issue along with a fix right away. At the end of the day, about 95% of the issues in our database that we track do have a fix. So sometimes the vulnerability existed before the fix existed, but like the vulnerability was known before the fix existed, but at least there is a fix. Catch now is that you need to know about it and you need to upgrade, and sometimes it's in a deep dependency. We'll talk about that in a sec.
Researchers finding this?
There are security researchers. It's still a fairly lightly researched space. Like if you compare it to Java or like to Maven or to actually, you know, like Ruby and Python are probably like similarly immature, but Java is quite kind of far along. You know, there aren't fewer vulnerabilities in NPM. Arguably, there are more vulnerabilities because of less security consciousness. They're just sort of less researched. Fortunately, that is now improving a little bit. It's still sort of a time to improve, and it's a part of me doing this talk, right? It's sort of encourage people's awareness to the issue. So let's talk about fixing this. So to fix this, I will use another version of Snyk's tooling, which is Snyk Wizard. And Wizard would help us identify these issues and would help us fix them. And I guess this might be a good time for me to also tell you that because we have a wizard and because my co-founder is a magician, we actually have magic wands for you as well if you want. Come by after and I'll give you one of those as well. They do roll back up. Where was I? I'm in the exploit one, so I'm going to run this in the actual parent directory. And what Wizard is going to do is, first of all, it's going to run the test again, so it would find those issues, and then it's going to walk you step by step as to how can you fix this issue in your code. So most of the time, there is a fix out there. So if you can upgrade, you should upgrade. In this case, the vulnerability in MS was, you see it's a regular expression, you have a link to it. I didn't use MS directly, I used humanize MS, which used MS in turn. So I can't upgrade MS, but the wizard would tell me that I should upgrade humanize MS to this newer version that would trigger the upgrade to MS. So we sort of traverse the NPM galaxy for you and kind of tell you which direct dependency upgrade you need to do. Sometimes it's simpler, like with Mongoose, it was just an old version that I was using, so I could just upgrade to it. Same goes for a bunch of others that we didn't review. And then sometimes, like in the case of Marked, there is no solution. So there's no fixed version of Marked. Marked has been inactive since mid last year. Or sometimes what happens is that there is a fix, but it's you're using A that uses B that uses C. C has a fixed version, but A does not have a new version that triggers that. That's especially common in new vulnerabilities that get disclosed, or newly disclosed vulnerabilities that just do not, the dependency chain takes a while to catch up. So in those cases, we try in Snyk to provide patches. Patches are backported versions of the original fix, or in the case of Marked, for instance, they're actually fixes that we at Snyk wrote. They are all open source. If I go into sort of the vulnerability description, if you look, it says Snyk patch available, and at the bottom you can see the patch. It's on GitHub. It's probably hard to read it, kind of remote. In general, feel free to go to Snyk. Oh, sorry. github.com/snyk/vulndb. That's our vulnerability database. You can go to the data npm folder and you can see all of these. For instance, if I go to Marked, which actually had multiple vulnerabilities on it over the last while, I can see the README, the overview, and I can also see the patches with syntax highlighting over here. So usually the fixes are quite simple. And also, again, most of the time those fixes have already been written, so we just backport them. And what we do here is we allow you to apply that patch locally so that you would fix the vulnerability locally. Now, Wizard would do this once, and we'll talk about how do you do it repeatedly. So I'm just going to patch this here, and patch these as well. And then, unfortunately, sometimes you do not, there is no upgrade, and we have not yet written a patch. If you come across this, we do accept pull requests. You're welcome to go to that vulndb and submit a pull request. We'll kind of welcome that. In the meantime, or if you don't do that, then you could choose to ignore the vulnerability. Ignoring vulnerabilities, you're ignoring a vulnerability, so you need to sort of assess and say whether this is an issue for you or not. But at least you will make Snyk stop reporting it as an issue. Yeah.
Is that modifying the code in your Node.js folder directly?
It is, yeah. So it basically finds the relevant spots and applies that changes. And if you browse to it, you would also find that it keeps the rig and you have the delta, but it actually modifies the code locally.
So would you recommend that using these people check in their Node.js folder?
No, I'll talk about how do you address this in a second. I do not recommend you check in your node modules, not for this purpose at least. Yeah.
Do you also modify the package?
Yeah, let me hold that thought for a moment and I'll show exactly this. So basically I'm going to say ignore. In this case, I also know that this is a, it doesn't make it, not in production, doesn't make it to production. So I'm just going to say I'm ignoring it for this purpose. This is for your audit purposes. This is not for anybody else's. So it just goes into your file. And now that I've addressed this, we're going to talk about package.json. So basically at this point, if I just continued, you will be free of vulnerabilities, known vulnerabilities in this system, which is good. But the question is, how do you stay free of vulnerabilities? Once you fix all of those issues, there are now two ways in which you can become vulnerable. One, somebody could add another vulnerable dependency to your package, right? Code changes, you add another dependency and it might add vulnerability. Two, a new vulnerability might be disclosed on your existing code and suddenly you have a vulnerability and you need to do something about it. The first step that's being recommended here is to add Snyk test to your package.json npm test. And what that would do is it would help you catch the first case. right? It means every time you run npm test, I'm going to say yes here. And in fact, I'm going to say yes to the next one as well, and I'll show you the difference in a moment. But what it does is it adds snick test to your npm test. So every time you run a test, hopefully in your build, in whatever automated test you do, snick test would run. Whenever you modified it to add a vulnerable package, the test would fail, you would see it, you would run wizard, you would address the issue. So hopefully you do this in a continuous fashion. The second question that I got asked here that I said yes is, do I want to add snick protect as a package.json installation hook? So if I go git diff to package.json, I'll see, first of all, I'll see this test, snick test. In this case, I did not have an npm test, so it created an npm test and added snick test to it. Otherwise, it would add it. And then the second thing we're doing is we're adding snick protect to your pre-publish step. Pre-publish is a really badly named npm hook, but it actually runs every time you run npm install on this project. So what this means is every time you run npm install, we would run snick protect. And what snick protect would do is look at this .snick file. So the wizard also created this .snick file, which includes a statement about which vulnerabilities you want to patch. So this information was stored in the .snick file, and when you run snick protect, it would apply that patch. Right, let me kind of back up a little bit because I explained it in a bad order. We run the wizard, you say what you want to patch, that information gets stored into a .snick file, and now every time you run snick protect, only those patches would be reapplied. So that means you don't need to check in your dependencies, it just means every time you run npm install on this project, snick protect would run and would apply those patches again. So you would be protected, you would fix the vulnerability repeatedly. It does mean that you need to add this .snick file to your deployment, to your package. And we will, the wizard would be smart, so it would add snick as a dependency of your app, either as a dev dependency if you just did snick test, or as a production dependency if you also need it for snick protect. One last bit that I want to show. I know I'm over, but I'm going to be 3 or 4 more minutes, if that's okay. I guess there's nobody after me, so unless you have to run home, I buy a few minutes here. So the last thing the wizard did, it also applied to the patches. It ran npm update, so if I run snick test here, again, I should be free. I should have no issues. Hopefully I'm not sort of missing something here. But it created the .snick file, and it added it to the production dependencies, etc. And then the last thing it did is it remembered your current dependencies for future notifications. So this is the second part. This is for the purpose of alerting you to new vulnerabilities that get disclosed on your dependencies. So basically what we've done is the wizard took a snapshot of your dependencies and remembered them over here. So I can go to my dependency tree, I can look at all of my dependencies, and now we have sort of this long list here. And this is Sneak, the service, remembering which dependencies you have. And now whenever a new vulnerability gets disclosed on these dependencies, we will send you an email. I'll show you a sneak peek at a new GitHub integration we have coming that gives you better notifications. But right now we will send you an email about those things. This was a current snapshot that we took. What you want to do is you want to run snick monitor, which is another command, snick monitor. You want to run that every time you deploy or every time you modify your package.json so that you will keep us up to date about which dependencies should we monitor for you, right? Everything I've showed right now, all of this works. You don't need to pay or anything. This is all sort of the free service. However, Snick Wizard, in order to do the snick monitor, does require authentication. So snick test and snick protect, they can be run anonymously. Snick Wizard, I was already logged in, so I didn't do it, but Snick Wizard will require you to register for free with your GitHub username, no repository access needed, just your username, just so that we can store these dependencies and we can alert you to them. Snick Monitor similarly would require authentication, which you can do with Snick Auth. The UI guides you to all of that. So this is basically how you address those. You run the wizard, you fix the issues, you put snick test in your CI so that you would repeatedly test and not add vulnerable module, and you run snick monitor every time you update your package.json so that we can alert you to new vulnerabilities that get disclosed. Let me do one more thing, which is show you a sneak peek at what's coming in a couple of weeks, just to sort of get the benefit of seeing it here, which is a tighter integration with GitHub. and then I'll kind of open it up to question. So today you have to do all these all the sort of steps that I talked about, which is as simple as we can make it. Really, you run the wizard, you just run this, it's a few simple commands. It's still effort, it's still a task. And we got a lot of requests to make this tighter, more tightly integrated with your GitHub repository. So this works on the test server here, but what we've added is the ability to test your repositories, which would actually show you your different repositories. You can test individual ones, or you can test all of your repositories. I have forks of various vulnerable projects that I've submitted pull requests to, so I apologize, there's a lot of these here. And basically sort of shows you the vulnerabilities on a bunch of your different projects. You can click and dig into each one of those just to be able to sort of find, see more information, understand. All of this is information you had in the wizard. It's just now it's kind of a little bit more web-based, a little bit more intertwined with your GitHub. And then the other thing you can do is you can actually integrate this. So I can come here and I can say monitor. It's actually a bit of a misnomer to do this only on the ones that have vulnerability. I can do it on the others because you want to get alerts for those. And what this would do is it would create that project. If I go to my monitor section here, I will see a bunch of projects that I'm monitoring. And I can see a history of my snapshots, which I only have one in this case, but it would capture this. So when I hit monitor, we integrate tightly with GitHub, which means we added a webhook. Every time you modify the package.json file, we will know and we will take a new snapshot. And it means when you submit a pull request, we add a sneak test to it. So you will see whether you're adding a vulnerability as soon as you submit the pull request, so you're going to get that notice. And then lastly, and that's not going to happen in a couple of weeks, that's going to be a little bit further out, when there is a vulnerability, we will submit a pull request to you with a remediation. So we'll submit a pull request that says, here's a fix. You need to upgrade or you need to apply a patch. Really trying as much as possible to bring this to you. Like basically, have it be a part of your current flow, not require you to sort of step out. So that's sort of what we're working on. I should kind of clarify about free and premium here. So test, protect, they can be run anonymously. They would remain free. All of this process that I've just shown here in terms of GitHub and all of that wondrous thing would be free for open source. And when you go into sort of private repositories, it's going to be some small amount that's free. And then after that, you pay some amount on a monthly basis. I'll stop here. So that's it. Questions? Yes.
Do you have like badging for GitHub projects where they can display like whether you're
Awesome.
testing?
I'll pay you later. That was a very good question. So we have this, in fact, for instance, the request repository has it. There's a vulnerabilities tab that you can add. So if you're awesome, you fix your vulnerabilities, you care about security, tell the world, add a badge. And in fact, when you run a test that has no vulnerabilities, if I go to like one of these projects that doesn't have an issue, we actually, I believe we encourage you to add a badge. You should celebrate and add a badge and tell the world that you care. Good question. Thanks.
Are there any special tools for module creators and publishers?
It's basically the same tool. Like as a module creator, you are also using, you typically also have dependencies. And the part of the reason that test and protect are so sort of free and anonymous is that you can use them without needing to put any keys or anything in your system. So if you have an open source project and you're using dependencies, you should stop propagating those vulnerabilities to your users. You should run the test, fix the issues, and if you need to patch any issues, you can run through the exact process I just described and make that a part of your package. And again, there's no keys are going to be needed in there. It's all like a part of the anonymous usage of it. We don't have any static analysis or something to find vulnerabilities in your code. That's not something we do. Yeah.
How do you get all this vulnerability into Sneak? Is there?
How do we find those? We search. We search hard. There's no, I guess our service or our kind of effort begins with just inventorying these vulnerabilities. So we have all sorts of listeners on keywords in GitHub, and we have a security team in Israel. Part of their job is to chase these down and find them. Unfortunately, vulnerability inventorying in general is messy, like even for things that do have a CVE, which is the formal databases, even those are very messy and you have to read through them. In the world of NPM, think about a quarter or maybe even less than that of these issues have a CVE. People just don't go through the formal reporting process. They just log them. So we just hustle, like we have a bunch of these listeners, we go through email lists, and we inventory them into that vulnerability database. So, yeah, there's a question back there. No, okay. No worries.
You were talking about the case where you have a module A depends on B, depends on C, which is the older version, and C's been fixed, but let's say A wasn't released as a fix.
Yeah.
And you may or may not have a back-ported fix.
Mm-hmm.
Have you thought about just patching the package JSON file to make it depend on the newer version? I mean, what's
the problem is breakage risk. So, you have A that uses B, right? Let's not add a layer, right? So you have like A that uses B, just for simplicity. A assumes that B is version 1.
Yes.
And now you go off and you modify its package JSON file to say, no, you're using B version 2. There's a pretty good chance you've just broken A. So when we write the patches, we reduce them to the bare minimum of the change that was needed without making any modifications. So basically, so far we've had a perfect track record for it, but we go through a lot of effort to make sure that we do not reduce or modify functionality. It actually came back to bite us a little bit in that. So have you heard of this image magic vulnerability that happened last week? There's, image magic had this massive vulnerability. And there was no solution for it. It wasn't really in Node, it was in the binary, but there's a bunch of packages that use ImageMagick. And we said, hey, can we do a patch that fixes that by disabling the vulnerable features? But the problem was that breaks functionality, so it doesn't fit our requirements in terms of what a patch is. So instead we posted a package called ImageMagick Safe, which disables the vulnerable features, but we couldn't make it as a patch, so. That's the reason we don't just upgrade, force upgrade. Force upgrade equals high risk of breakage. Yeah.
I imagine this is very powerful as organizations develop lots of what becomes legacy code, legacy node applications that have been running for a long time. There are people who are familiar with those things anymore, so it's going to take a lot of time to familiarize somebody before they can actually fix what the bug is. And if you can have some assurity that you're not going to get behavior, but catch the problem, that's saves the company money.
It's true. Basically, patching, you need to patch in one of, I guess there are 3 scenarios. One is there is no fix. You need to either have a vulnerability or patch. 2 is there is a fix, but you can't upgrade to it because, like, physically, A doesn't have a version that uses the fixed version of B. And 3 is there is a version of A, but it's a major upgrade. So you need to modify your code for it. We've actually seen this all the time with handlebars. Handlebars has a vulnerability that was fixed in the 4x stream, but not in the 3x stream. And people using 3, it's a big deal to go to 4. It's a breaking change, so you need to make effort. So that's especially problematic when those people went away. Is there a fire or something, or? No, okay. Just the, okay.
Too much security.
Too much security. Fail safe. So yeah, but it's a good observation. It's basically, sometimes it's because you cannot upgrade because of the NPM's dependencies, and sometimes you cannot upgrade because you can't in your code base, or you can't take on that risk right now. Yeah.
What do you do for security education?
These talks. I will say that security as a whole is a much bigger space than just what we're dealing with here, and specifically node security, and there's many aspects about how do you not write this type of vulnerable code in your own application. Realistically, you can't expect all developers to become security experts. It won't happen. We have other aspects, other things that we're doing, and you also can't expect, especially in these open source projects, you can't expect one developer to have the entire skill set. In a team, it's reasonable to say, well, somebody on that team would have some security expertise, right? Or that foundation or that corporation has invested in security tools. But when you have these projects that are driven by 1, 2, 3 people, they oftentimes it's really not at all a lack of investment. It's just a lack of knowledge, a lack of expertise. We're trying to sort of raise awareness to it. I would encourage all of you to do so. The badge is an aspect of that, just sort of telling everybody they should care. And we hope to sort of help promote this notion of security as quality. Security is an aspect of that quality. Having Request put this as a badge, promoting this elsewhere. There's a lot of these components that would add up. For us, our intent is to continue sort of building this, but also help you take the next step of tracking these open source components and understand how are they behaving in production, what are they doing, fine, you have all these components, which one is writing to the file system, which one is connecting to the network, do you really want to allow that? There's many of these aspects, so we're kind of going deeper into this specific threat versus going into doing static analysis, which is also lacking, but we can only save the world one problem at a time. Other questions?
What's your background?
Sorry?
What's your background?
What's our backend? It's Node.
Your background.
My background. Where do I start? I'm Israeli. I was a part of the team that wrote the first web app firewall, App Shield, working for a company called Sanctum that got acquired by a Canadian company called Watchfire. Moved to Canada in the process. Watchfire got acquired by IBM. Left IBM, started a web performance startup called Blaze. Got acquired by Akamai. Was the CTO at Akamai for 3.5 years. Moved to London in the process. Left Akamai, founded Snake. That's my brief. On the O'Reilly programming committee for a bunch of conferences, wrote 2 books for O'Reilly. I don't know. I can send you a link to my bio. So I've been in security. I guess what is interesting is that I feel like I've been in security for over a decade. I was also in the cyber parts of the Israeli army, and I moved to performance for 5 years, and that was really enlightening because in performance, like you go to a security conference and you come back and you kind of want to curl up and cry. There's this, everybody's breaking everything and it's all this very confrontational and all that. And you go to like Velocity, you go to these performance conferences, you come back like all energized, right? They're like, we want to make the world better. We sort of go at it together as this like community of people that want to help me. And I think there's immense value in trying to bring some of that mindset into the world of security. And it's hard because security is insurance, right? You're going to do this and you're not going to make more money tomorrow or be more successful tomorrow. You are reducing the chance of having something horrible happen tomorrow. But that's a very important difference. So I think it has to be perceived as an aspect of quality. It has to be perceived as somebody that's everybody's responsibility for this to improve. And I guess for me, I'm kind of trying to take some of the learnings from that side and bring them over to this one.
Give it up for Guy.
Got magic wands for those who want it.